Hi there, welcome back to my channel, or welcome to my channel if it is your first time here. Today, I thought it would be kind of fun to just sit down with you for a little bit and go through this psychology textbook. This is the 4th Canadian edition of the World of Psychology by Samuel E. Wood, Ellen R. Greenwood, Eileen Wood, and Serge Desmarais. So about 6 months ago, I decided that I wanted to read this textbook. It goes through kind of the psychology basics, the history of psychology, how psychology has become what it is today, developmental psychology, behavioral psychology, abnormal psychology. There's a little bit of everything in this book. It's kind of like an introduction to the different fields of psychology. It took me a couple weeks, but I read through this textbook and I made my own little workbook out of it. But I did this because I am going into my specialization in psychology, and I wanted a little bit of an idea of what I would be getting into. So I found this textbook online. It's not a current textbook. It's not a current textbook. This one was published first in 1996, so 25 years ago. And then there was different editions of it released, and the last edition released with this one was released in 2005. But I figured that's okay. Regardless of if it's new, it'll still give me kind of a solid understanding of the different fields of psychology. And it would just be a cool read. So I just thought it would be kind of fun to sit down with you and go through some cool psychology facts from this textbook. At least that's fun to me. If you don't find this interesting, still stick around because maybe it will bore you to sleep. Alright. So this is Chapter 1, Intro to Psychology. So, this is kind of the boring stuff. Research methods, case studies, different types of research techniques, how to select participants for a case study, different techniques for selection. Let's flip to then it goes over the biology, the physiology of the brain, how the different sections of the brain, which is actually quite interesting to me. So here we have a diagram of the brain. Let's go through this diagram of the brain. So there's the spinal cord, which is an extension of the brain. Controls simple reflexes, connects brain to peripheral nervous system, which include the nerves that branch off from the spine. So there's the PNS, which is the peripheral nervous system, and the CNS, which is the spinal column, and the brain, the central nervous system. Okay, and then we've got this little area right here, the medulla. It's the control center for the heartbeat, breathing, blood pressure, swallowing, and coughing. So any sort of involuntary things that occur within your body, like we don't need to think about keeping our heart beating, keeping our lungs breathing, and any reflexes, automatic reflexes like coughing is an automatic reflex, swallowing. That's the center of the brain that just regulates all of those things and makes sure that all of those reflexes are functioning. And then we've got this little area right here. This is the pons. It plays a role in relaying motor messages between the cerebellum and the motor cortex. Exerts influence on sleep and dreaming. So this section here, the pons, right here, there's been research done on the pons that shows that neurons begin firing a lot quicker within the pons as you fall asleep. So it's believed that the pons plays a role in dreaming. And then the last part of the brainstem is the reticular formation. This is the arousal system. It activates your cerebral cortex, which is up here. It plays a crucial role in attention as well. So the reticular formation screens messages as they're coming in, because we are constantly receiving way too many sensual messages. Our senses are always firing. There's no way that our brain can process all of that information all at once. So the reticular formation actually acts as a filter for all of these sensual stimuli that comes in. And it basically screens, it blocks some messages, or it lets through some messages to the higher parts of the brain for processing, but that is what keeps our brains from being bombarded with constant stimuli. Also, it plays a role in how alert we are. So as the reticular formation slows down, we tend to doze off or fall asleep. Okay, what else do we have here? We've got, just right here, we've got the cerebellum. This coordinates skilled movement and body balance and affects muscle tone. So this is basically what controls our movement, what coordinates our movements. It helps us be able to control our body. The cerebellum is responsible for muscle tone, muscle activation, and coordinated movement. So our walking, our ability to dance, our ability to play sports really relies on the functioning of the cerebellum for smooth, graceful movement. And it helps us retain memory of motor activities, and it's believed to play a role in motor development. And then there's this right here. So then, for moving on up here, we've got the thalamus. It's the relay station between cerebral cortex, which is the upper part of the brain, and the lower brain centers. So this is basically the communication station for messages to be passed up into the cerebral cortex and into the different lobes of the brain for interpretation. It takes the stimuli or the messages and interprets it, basically sends it where it needs to go in the brain within the different lobes of the brain, the cerebral cortex. Then we've got the hypothalamus, which controls functions such as hunger, thirst, body temperature. It helps to control the endocrine system, and it's involved in emotion. So the hypothalamus, which is right under the thalamus, really helps to regulate how we feel and our senses. For example, my hypothalamus is telling me that I'm hungry right now, which is why my stomach is growling. So that is essentially the brainstem, and then we've got the limbic system within our brain as well, which is quite interesting. They are structures deep within the brain, and they control emotion and play a crucial role in the formation of memories. So when people experience traumatic brain injuries or anything of the sort, that results in memory loss, there's usually some sort of damage to those structures, especially the hippocampus. So if you've ever seen 50 First Dates, where Drew Barrymore can only remember the one day, and her one day repeats every single day, she can't form any new memories. She only remembers she gets into a car crash and damages her brain, and she only remembers everything that's happened in her life up until then. So basically, she experienced some trauma to her brain that results in her being unable to form new memories. So that would actually be damage to the hippocampus, causing her to be unable to form any new memories, which is quite interesting. Okay, so in the limbic system, we've got the amygdala. The amygdala plays a role in our sensation, particularly how we respond to unpleasant stimuli. It also plays a role in our learned fear responses, in retaining those memories in order to protect us. So fear responses are processed within the amygdala. For example, you may have experienced something that scared you, so that was unpleasant, such as a bee sting or something like that, that causes you to fear that causes you to fear this thing. Often people who have negative experiences develop a fear response to the thing that they had the negative encounter with, which is interesting. That process happens within the amygdala. If someone has damage to the amygdala, they can actually experience an inability to recognize tones of voice, facial expressions, emotional responses. It can be impossible for people with damage to the amygdala to recognize those kind of social cues and emotional cues in other people, which is so fascinating. And then, yes, like I was saying, the hippocampus is responsible for the formation of new memories. If it was destroyed, you would not have any memory whatsoever of anything from there on out, but any memories that you have from before that would remain intact. And then there is that part of the brain with all the folds that we all know a brain to look like. That's the cerebrum, the lobes of your brain. It's the cerebrum, and then those two, the left side of your brain and the right side of your brain, are connected at the bottom with a thick band of nerve fibers called the corpus callosum. So that helps to transmit messages back and forth between each side of the brain. It also helps you to coordinate activity between the left hemisphere and the right hemisphere. So, for example, coordinating vision out of both of your eyes and movements and such. So there are 4 lobes in the brain on each hemisphere. So each hemisphere of the brain has 4 lobes. We've got the frontal lobe, the parietal lobe, the occipital lobe, and the temporal lobe. Okay. We also have, in between the frontal and the parietal lobe, the motor cortex and the somatosensory cortex. So the frontal lobes are the biggest lobes of the brain. They include the motor cortex, which is responsible for voluntary motor control. So the left hemisphere of the brain actually controls the right side of the body, and the right hemisphere of the brain controls the left side of the body. So the parts of the body that require more fine-tuned movement, for example, fingers, tongue, lips, the areas that control the movement in these muscles actually are actually larger than in areas that don't require as much fine-tuned movement, such as our arms, our legs, and then our lower part of our body, so our toes, our legs. The lower part is mainly controlled by an area at the top of the motor cortex, and our upper bodies are controlled by the bottom of the motor cortex. So it seems that everything within our brain is kind of flipped. So if we have damage to a part of our motor cortex, it can result in the loss of function in certain muscles, paralysis. Damage to certain areas can result in seizures. And if we have a limb amputated, this is actually pretty cool. If we do experience having a limb amputated, the neurons that would fire to control these areas will eventually just be utilized and dedicated to another function. And then there's also within the frontal lobe a little area called Broca's area, which is responsible for the formation of speech production, the movement of the jaw, lips, anything involved in speech would be influenced by Broca's area. And if there's damage to that, if there is damage to the Broca's area, the individual would likely be unable to speak or only able to speak very, very little. Damage to Broca's area can also result in something called Broca's aphasia. Aphasia is the inability to recognize speech, to understand speech. It causes you to be unable to use speech. So people with this, with damage to Broca's area, it's so frustrating because they know what they want to say, but they cannot communicate it through speech, which I can imagine would be extremely frustrating for those individuals. There's also the frontal association area, which is responsible for like planning for the future, motivation, emotional responses, impulse control. Individuals with damage to this area will likely struggle with impulse control and emotional responses. It really affects kind of the personality almost. Okay, and then directly behind the frontal lobe we have the parietal lobes, which play a huge role in processing touch stimuli. So temperature, pressure, any sort of sensation would be processed through the parietal lobes. It also helps us maintain awareness of the position of our bodies at any given time. So we are aware of where our limbs are and our coordinated movements. So I know that my feet are here. I can sense that they're below me. I can sense that my hands are away from me. Stuff like that. That's also processed within the parietal lobe. So in a person with a normally functioning parietal lobe, they would be able to tell the difference between something soft something rough. I can feel the difference between scratching and just rubbing my arm. If you have damage to specifically the somatosensory cortex, which is a strip of brain kind of bordering the frontal and parietal lobes, some people with severe damage to this area can't even tell the difference between something extremely rough and something extremely soft, or they might just have no sensation at all. There are also parts in the parietal lobe that are responsible for spatial awareness and your sense of direction. The occipital lobe, which is at the lower back part of your brain, are responsible for visual stimuli, sight, and interpretation of any visual stimuli. The primary visual cortex is located in the occipital lobe, and that is where our vision registers. So both of our eyes are connected to the left and right sides of the occipital lobe, and both sides of the brain, both eyes connect on each side. So if you focus on an object, preferably closer, it's more obvious when the object is closer. So focus on your finger and close one eye and the other eye, and you can see how the different sides of your brain are registering the image differently, and our vision comes together to form one complete image. But we are actually, when we look at objects, that's why we can see in 3D, because when we look at objects, we are actually seeing it from different angles from each eye, and our brain processes it all together, and that's what's responsible for our 3D, our ability to see things in 3 dimension. If there's damage to the association areas within the occipital lobe, that's where we store our visual memories and our ability to recognize things that we have seen before. So, for example, if you have damage to that area, you can be shown an apple, and you can look at this apple and not be able to visually identify it. You won't know what it is. You will be able to identify it by touching it, smelling it, but visually you won't know what it is, because you can lose your ability to visually recognize things, which is so fascinating that individuals with this type of brain damage can still identify objects. They don't lose the memory of what the object is, they just lose the memory of how the object appears visually, and they need to relearn this. And then we've got the temporal lobe, which is where hearing is processed and understood, auditory stimuli. It's involved in the reception and the interpretation of auditory stimuli. The primary auditory cortex is where anything you hear is processed. There's also an area within the temporal lobe called Wernicke. I'm not really sure how to pronounce it, but Wernicke's area, which is involved in comprehension of speech and the formation of coherent speech and language. Lastly, we've got temporal association areas, which is the area where auditory memory is stored. So that's why you can recognize certain sounds, such as a cat's meow, a dog barking. If you hear the barking sound, you know that it's a dog barking. So this is what's responsible for recognizing familiar sounds. And there's also a space where melodies and songs that we have heard before are stored too. So this definitely turned into a neurobiology lesson, which is super interesting to me. I can talk about the functions within the brain. I can talk about the functions of brain structures all day. I find that so fascinating. I'm by no means an expert at all, but it is something that I'm very interested in learning about, and something that I hope to be able to work with in the future. So I hope that you found that interesting and informative and relaxing, and if you didn't find it interesting, I hope you found it boring enough that it put you to sleep. Thank you for sitting with me, and thank you for listening to my little chat about the brain structures. do like videos like this, let me know, because there's so much more that I could talk about in regards to psychology. I can dive into different chapters within this textbook if you'd like, and get into some other interesting topics. So let me know if you enjoyed this video. Give it a like and subscribe, and thank you